This is the fundamental diagram of traffic flow. So these three diagrams are very much important from the exam point of view, as well as the relationship between the speed, density and flow. So equation wise, so that is called Q equal to K into V. So that means flow or volume equal to density multiplied by speed. That is the relation. So how individually these affect each other? So the flow and density or these fundamental diagrams, this vary along with the time as well as with the location. But a generalized way it has been expressed, the relationship between flow, density and speed. So the speed and flow can be represented with some certain curves. Okay, so these are the curves and these are basically referred as the fundamental diagrams of traffic flow. So now I will explain one by one. So here density. Density is the number of vehicles per unit length or number of vehicles per kilometer of a road at an instant. So here the vehicle density of a road is expressed as number of vehicles per kilometer of the road, while this is the speed, that is the distance with respect to the time. So here when there is an increase in speed of the stream of vehicles on a roadway, the average density decreases. Okay, so a linearity is shown here. That is a simple assumption that variation of speed with density is linear. So that means corresponding to the 0 point, that is the zero density, vehicles will be flowing with their desired speed or say the free flow speed. But when the say density, so when the density is reaching the jam density, the speed of vehicles become 0. Okay, so this is the density that is called the here as jam density. So in that case the speed of the vehicles will be tends to 0, because density means number of vehicles in a particular stretch or kilometer. So if the number of vehicles will be very much high in a particular point, so how can the vehicles move or how the vehicles can go with a free flow speed or with their desired speed? They cannot move because there are too many vehicles in a particular road stretch. So in that case what happens? The speed gradually reduces when the density increases, and when there is density tends to 0 means there are no vehicles. Density 0 means there are no vehicles or very few vehicles in a particular stretch. So that times at a particular section any vehicle can move at a higher speed. But as there is a congestion, that is basically called the jam density here, so the number of the movement or the speed of vehicles gets restricted. So the speed and density, it is shown by a linear diagram here. Next is the speed versus flow. So in this case the relationship is shown by a parabolic curve. Okay, so here at a particular point, say at this point, there is an optimum speed at which, so at this point there is an optimum speed at which the flow or the volume is maximum at higher speed. Okay, so initially there is a, suppose the flow is 0. Initially if the flow is 0, this is because there are no vehicles or there are too many vehicles so that they cannot move. In that case the flow will be 0 here. So at a maximum flow point the speed will be in the range of 0 to free flow speed. Okay, So there are, that's why there are, initially I have told, that is there are 2 points. So either there are no vehicles, okay, that's why the flow is here 0. Then here it is possible to have two different speed, okay, so it is possible to have two different speed data for a given flow. Okay, if this is the flow point here, so there you can see there can be the two different speed data. So here it is obvious that at very low speed the traffic flow or volume will be 0, but with the increase in speed the traffic flow also increases up to a certain point. Okay, but as the speed further increases, the spacing between the vehicles, so here it is properly judged by the headway. That is, headway, there are two types of headway, one is time headway and another one is the space headway. So space headway is basically the distance between the two vehicles, that is earlier I have told bumper to bumper. But time headway is basically the time difference between any two successive vehicles when they cross a given point. So in this case what happens, that as the speed further increases, the spacing between the vehicles becomes so large that the time headway between the vehicles also increases. So because the time headway increases, so there is a decrease in volume. So the relationship, that's why it is a parabolic curve shown here, that thus at each value, that is each value of flow, there are two speed values only because of that headway relation. Next is the flow and density curve. So here what happens, that when the speed of the traffic flow decreases and becomes say 0, so when the speed becomes 0, so then density will be maximum because there are too many vehicles in a particular road stretch. So that's why the speed getting 0 or reduced because of the congestion. So then what happens, that as the density is maximum, then at that point the volume becomes 0 because number of vehicles passing a point at a particular time is not valid, because for the congestion the vehicles are moving in a very slow rate. So in that case, with the increase in speed value, the density value decreases, and there is, with the increase in speed value, the volume increases up to a certain limit, and again it again decreases. Okay, so in this relation what happens, say when the density is say 0 at this point, the flow will also be 0 because there are no vehicles on the road. But as the number of vehicles gradually increases, the flow as well as density both increases. Then at a point when more and more vehicles are added, it reaches to a situation where vehicles cannot move. So this is referred as the jam density or the maximum density. Means at jam density flow will be almost 0 because no vehicles are moving. Then there will be some density between the 0 density and the jam density. So when the flow is say maximum, so this is also another parabolic curve represented here. So here at this point the flow is maximum, okay, but then after some time as the flow value changes, so then there is an increase in here density here. So simply at this point, this is the jam density point, that is the K jam you can say. So at this point flow will be very less, and this is the point where this is the maximum point of the flow. So by this diagram these things are very much vital, that this is the maximum density point as well as the K maximum, that is the density maximum. This is the jam density point, and this is the optimum point for the speed and flow, and here this is the Kj, that is the jam density point. So that all thing you have to elaborate, and sometimes a 5 marks question comes that express the relationship between the speed, flow and density. So you have to draw these 3 diagrams as well as you have to note down the relation that I have earlier told, Q equal to K into V, that is the average flow or that is the flow or volume equal to the density into the speed.